All right, so in that last video, we learned that if you just plug in the value and it works, great, that's your limit. The limit exists, that's the answer, and you can basically go home. Everything's done. But what happens if we run into a situation where the limit doesn't exist? What does this look like? So basically, when a limit doesn't exist is when you run into a situation like a number over 0. There's a couple interesting situations, and once again, you can find it up here. You're either going to get a number out of it, or you're going to get a number over 0. This would be the asymptote, which would be something like this. And then you have that vertical asymptote, which we know for sure the limit's not going to exist at a vertical asymptote. The other situation is 0 over 0, which is indeterminate form, and further investigation needs to happen. This would be the one where you have that removable discontinuity, like that, where the limit probably exists, just the point has been removed. You're going to end up with 0 over 0. Compared to a number over 0, the limit's not going to exist for sure. And so, and once again, if you just plug in the number and you get something out, that's it. That's your answer. So let's look at this. We're really looking for when a number over 0, if you end up with a number over 0, it's indeterminate, or it does not exist. It's a vertical asymptote probably, so the limit doesn't exist. If you end up with 0 over 0, then more work needs to be done. Why don't I just write that down just so we know that? So if the limit as x approaches a equals L, then that's your limit. That's good. If the limit as x approaches a equals, let's just say some number, we'll call it b over 0, then more than likely limit does not exist. And then the limit, let's just say we get 0 over 0, then more work needs to be done. The limit probably exists, but we're going to have to go approach this in a different way, which is honestly where we're going to spend most of our time in the algebraic limits. And just to draw a picture, just so we have that. So this is a vertical asymptote. This one's just a regular function, things are just going along. Things are fine. This one, more than likely, you're going to have a hole in the graph. Okay. So let's look at the algebra. Let's go through some examples. So I'm going to start by just plugging in the 5. So we get 5 plus 2 over 5 squared minus 5, which is 7 over 25 minus 5. So 7 over 20. So guess what? We got an answer. It's a fraction, but it's an answer. So it's like this one. The limit exists. We're good. You plug it in over here, and really you just have to look at the denominator. You can already tell 8 minus negative 5. That's not going to be 0. So that's also going to give you an answer. That's fine. It's okay to have a 0 on the top as long as you don't have a 0 on the bottom. Looking at this one though, let's plug in the negative 3. You'll see right away. Negative 5 over negative 3 plus 3 squared. It's negative 5 over 0 squared, which is, well, that's undefined. So the limit does not exist. Same thing over here. If you plug in the negative 5 down here, you'll see negative 5 plus 5 is 0 on the bottom. So also there, the limit wouldn't exist.